Good day, learners! We are here to provide help for you if you ever have a problem regarding the subject physics. So our topic for today will be orbits and Kepler's three planetary motions.
Planets orbit the Sun in a counterclockwise direction, and the planets' orbit are all aligned to what astronomers call the ecliptic plane. Kepler realized that the orbits of the planets are not circles, but were instead elongated or flattened circles that the geometers call ellipses.
Since the orbits of the planets are ellipses, let us review the three basic properties of ellipses.
The first property of an ellipse. An ellipse is defined by 2 points, each called focus and together called foci. The sum of the distances to the foci from any points on the ellipse is always constant.
The second property of an ellipse. The amount of flattening of the ellipse is called the eccentricity. The flatter the ellipse, the more eccentric it is. Each ellipse has an eccentricity value between a 0, a circle, and 1, essentially a flat line, technically called a parabola.
Property of an ellipse. The longest axis of the ellipse is called
The law of planetary motions was derived in the 1600s by the German astronomer Johannes Kepler.
First law, law of ellipses. All planets move about the Sun in elliptical orbits, having the Sun as one of the focus of the ellipse.
Second law, law of areas. A radius vector joining any planet to the Sun sweeps out equal areas in equal length. In simple words, when a planet is far from the Sun, it moves slower, and when a planet is near from the Sun, it moves faster, so that the area will be equal.
This law shows that the farther a planet is from the Sun, its orbital speed is slower, and the nearer it is from the Sun, the planet's orbital speed goes faster. This law makes a comparison between the motion characteristics of the planet. T squared over a cubed is equals to k for all planets in the solar system, where T is equals to orbital period of the planet, A is equals to average or mean distance of the planet from the Sun. It can be observed from the data that the ratio is quite the same value for all the different planets by using the T squared over A cube ratio.
How does Kepler's third law relate to Isaac Newton's law of gravitation and centripetal acceleration? In 1687, Newton discovered that Kepler's laws applied on the solar system as a consequence of the law of gravitation.
Kepler's law of planetary motion also holds other systems wherein there's a massive central object, not necessarily planet.
Created using Powtoon.